And let's take a look at our notes right here. Also note, if you haven't figured it out already, I only answer questions related to the stream. So if you type something in chat and it doesn't have anything to do with the stream, I will not answer. I will not even acknowledge. Okay. We left off, we were dealing with error handling in the sound.c module, which is intended to be used by CFFI. And so, is there any way I can get my hat more visible? Cap. That's good enough. Okay. So you can go to todd.k.fisher.github.io. You can read the full text, but the long and short of it is we have to fix a problem with the way sounds are referenced by the client. Playback is referenced by the client. Client is the caller of sound.c. So as it stood in the last stream, the use case would be client request playback calling play memory async or play file async, and an index is returned on success and the sound begins playing. And then sound cancellation happens. Basically what that does is it frees Miniaudio resources, a decoder and a device. And that occurs if cancel async is called, where an index is passed, or the playback completes, which just cancels it all the same, or just frees the resources all the same. So that's not the right way to do it, because picture the following scenario. Steps 1 through 3 happen for a particular sound A, say. After playback, client requests playback of another sound and receives the same index as in step 2 above. And then perhaps another part of the client code believes the original playback is still in progress and requests cancellation. So what happens is the new playback is canceled instead of the old one, because the resources for the old playback are being reused and they're only referenced by index. So a solution is to modify the play functions to return a pair serial number resource index. Serial number is unique for each playback request. I have a footnote here. Serial number and resource index pairs are smashed into a single uint32, where the CFFI client will pass, which the CFFI client will pass to cancel async. I would prefer to return 2 values, but I don't know of a simple way to do this in CFFI at the time of writing. To cancel, sound cancel SND, that just references the sound module, or that's just a prefix on the sound module functions. Sound cancel async would take the serial number and index as parameters, and if the client attempts to stop playback with a serial number that has expired, it's an error condition. Now, what does that mean? I'm going to bounce down here. So resources store this should be renamed. This should be sound playback identifier or something like that, and we'll fix that. But the idea is that's stored. This struct stores or is used to manage Miniaudio resources, and if you pass in an identifier that doesn't match this, then it's an error condition. And of course the serial number gets bumped up each time the playback happens. I suppose you could have a per index or per resource serial number. So instead of serial numbers being shared by, I think there are 25 instances of this sound struct. So instead of a serial numbers being shared, they could just be private or private to each struct. But that's not what I plan. Okay, so since the serial number and the index are smashed into 32 bits, what does it look like? The first 6 bits are the index, and for reasons I will explain that will be clear, you really 2 to the 63 is excluded because all ones here signify error. So you get 62 simultaneous sounds. It could be changed. And then the rest, that's the serial number. So you have 26 bits for the serial number, which gives you approximately 67.1 million playbacks until it wraps around. And I have a note here. This scheme won't work if we have sounds that repeat endlessly. So it's certainly possible that 67 million sounds could have been played, and wraparound could clobber any long-running playback. I don't suggest a fix there, but they have to just somehow note that some continuously playing sounds are special, and their indices, their identifiers, or their indices rather, and serial numbers cannot be reused. Okay, so since we must also signal error conditions to a caller, and since we're returning a single unsigned integer, 32 bits, some range of possible values must represent an error condition. And so I just chose to make the lower, this is Little Indian, by the way, make the lower 6 bits as 1. And so maybe that we'll change that to bit fields. I haven't used bit fields very much. Also, as I note on the next note, if we were to take these 3 bits, or I'm sorry, 6 bits, put them over here, then we could do a simple, slightly simpler test. We could just say if playback ID is greater than or equal to that, FC da 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 da. Note here, this is big endian. Then we have an error condition. But what we have to do now with this scheme of using the lower 6 bits of all ones to signal error is we have to do a logical AND with 3F. And I believe we need to fix that code. So logical AND with 3F equals 3F. No. as opposed to, yeah, that should be equal to and then 3F. So there's a little bit of an error. Let me fix that right now. Embarrassing. Let's see. I'm taking this hat off because it's not very comfortable. We'll just, I'll just put it over here so that you know who's in charge. One other thing to note, keep in mind, is that I have refactored my Emacs init file. So there might be small forays to fix small things that I didn't catch when I tested my refactoring. Okay, what do we want to do here? We want to say let's push these changes up to GitHub. And when I push them up to GitHub, then they'll show up on my webpage. Did I not want to do another change? Okay. Let's see. Okay. Yes. What footnote was that? Footnote 6. Okay, and it will show up in a few moments. There it is. Okay. So, today's agenda, this evening's agenda. I forgot to set my hourglass. I really don't want to work more than an hour. Or stream more than an hour. So I've written the code to create and extract serial, to do the bit smashing for playback IDs, but it's not used anywhere. So we need to start using it. And then finally, time allowing, walk through sound.c and informally convince myself that there are no race conditions or deadlocks, and I do stress informally. Hopefully that's sufficient, because it's not, the threading isn't very sophisticated. It's a simple condition wake up and couple of mutex locks. One mutex lock. There's only one mutex. One mutex, one condition. Okay, so let's let's see. So what do I mean by I've written all the bit bashing code? So we have a smattering of functions. Let's see. Let's start with the easy one. Get the index. Well, index is the lower 6 bits, and so we just grab them right there. The serial number. We mask off. We zero out the lower 6 bits, and yes, serial numbers scale by 64, because who cares if the lower 6 bits are 0? All that matters is that this thing gets incremented. These will never get incremented. So when you return the serial number, the first one would be 2 to the 7th, which is what? Is that right? 1, 2, 3, 4, 5. Did I think I'm missing something here. Yeah, 2 to the 6th. Yeah, so 2 to the 6th. The first one, the first serial number would be 2 to the 6th. Did I make an arithmetic error somewhere here? I don't think so. Okay. So serial numbers are 2 to the 6th and larger. Never lower. Just because it doesn't matter. Okay, they're just magic cookies. Okay, so we have get serial, get index, then set serial and index. So we zero out the old index, grab the old index, zero it out, and then orient the new index. Which you'd better, we should probably do this, just in case some smart aleck decides to pass in an index larger than whatever this is. What is it? Hex 3F. So just by the way, I have the patio door open because it's a nice day out, or a nice evening. There may be some outside noise. What do we want? We want to mask off the low. We want to. My mind is drawing a blank. We want to mask off the low 6 bits. And so what's the easiest? We should say and SND 1 bits 26 shifted left 256, right? Yeah. There. Okay, so, and let's just parenthesize because for some reason the bit manipulation operators in C have a funky precedence. Okay. Check to see if there's an error. Okay. So what's our let's just start with easy functions. Let's generating serial numbers. Well, what's the first serial number? We said it was 2 to the 6th, right? So and then we have to deal with error codes, which the more I look at this, the more I begin to wonder if bit fields would be a better idea. That way we can just we don't have to worry about the shifting and masking and all that. Let's just go ahead with it. Error codes. 26 bits of error code, which we'll never use. So we have, so far, I believe, we have 4 errors, no free slots. We are the sound module instance is currently in error state, and what that means is that Miniaudio returned an error code, so we refused to do anything else. That was the last live stream. Sound is already canceled, or as we talked about earlier, we have an invalid serial number, maybe others. So let's see. 0. Okay, so what we're doing here is, so we can just very easily do a compare. Is we take 6 1 bits and then we tack on the error code starting from 0 right here. Let's do highlight line. Okay, and that's also while we're at it, Control X, Control plus. Okay, that way people can see. And so no free slots is error code 0, but it's really, we just put the 6 1s onto it. It doesn't really matter, of course. Well, I think since it's a little dark out, I'm going to close my patio door. And let's see, any questions? No. Any viewers? Who cares? I find the noise. I'm going to check viewers on my phone. That way I won't get feedback. I guess there's a better way to do it. One watching. That's probably me. Okay. 1 second. Okay, so let's just deal with incrementing serial numbers. Is there a simple way to do this without, let's see. The very first serial number is hexadecimal 3F, which means all 0 bits. No. The very first serial number is I'm sorry, 2 to the 6th, which is 64. So what we have to do is, well, no, it's not 2 to the 6th. It's the very first serial number is that's really not for a given index. The very first serial number is that index, and I'm just going to do this because I think we'll just put this here. uint 32t g serial, and we'll just set that to 0. And then we'll just take the bits from serial, shift them, and OR them on to the index. So I'm kind of anticipating what kinds of function I would need here. We will call this make it static. Sound make ID, and that will be okay. So we'll limit indices to 8 bits. Do we do this up here? No. And do we do this here? Okay. Put some comma here. I'm just going to say smash G serial and IDX into 32 bits as described in here. I'm not going to repeat that. I'm not going to repeat the comment again. I might move the comment to here later. So what do? We take G serial, shift it left. Okay, so shift it left by 6. And then we OR it with UINT, I'm sorry, IDX, and I like to use the this little, I think this is an inline function, is it? Of course, it doesn't find it. My LSP server, my LSP client, or my server. Maybe this, yeah, probably the server. All right, so if I have something that's syntactically correct, can I find it? No, oh, SND, yeah, there we go. SND 1 bits, SND, for SND for sound. And there, I found it. Okay. And we're post-incrementing the serial number. No, we're not. And we have to do something like this. Right? So we never let it get larger than 67 million or whatever that is. We never let it get larger than 26 1 bits. And then okay. I believe that's it for all of our utility functions. Let's see. Let's go down and let's. What I should probably do is I should probably make a little checklist here. Are we in org mode? Let's make ourselves a little checklist. I'm not going to be fancy with yes, I am. Control Shift Space, the global mark, because see how this works. Oh, I don't like that. I want my auto numbering. Or there. Okay, so we'll just go back and forth. Find available slot. Next. put some comments on some of these. I don't like comments usually I don't like comments except above a function and above a file and to document the members of a structure. I don't like extensive comments. We might get through all these tonight. Okay, and for those of you wondering, what's this? Why didn't I use character? It's just because I don't do Unicode, that's why. Should we? Yes. Should we check the destructor and constructor? Yes. I'm using forward paragraph. I wonder, is there like a forward def on? Oh, I don't see one. Okay. And let's do this. Make it into a checklist. There. See if it works. Okay. All right, let's go to sound check call fail. Okay. Let's see. Okay, so this is from last stream. I'll repeat something from last stream. We have a flag, very crudely named something failed. Okay, this is called by a macro. And so what it does is, let's take a typical use. Look for it. So check call fail. It's a little macro. If you expect success and you don't get it when you call this code, then it will pass the function call, the text of the function call, and the line number to this little function. And it's definitely not going to get a uint32, is it? Because underscore underscore line underscore underscore is a string. And we'll deal with it. Okay, so we found one unrelated error. So this error code is, we have two varieties of error codes. This sound check call fail is only meant to be used with Miniaudio functions. And so what I should do is rename this G error code. G means global. That should be G Miniaudio error code. And we'll fix that. That's not our error code. Let's deal with that. G error line equals what? A to I. Yeah. Okay. So let's deal with this name here. Can we just call it MA error code? We'll go up here, we'll change things, G. Yes, 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 okay. And I guess I don't have a declaration for that. Okay. Okay. All right. Return and what were those things? So I need to know how big the error codes are. This may or may not work because MacLeod does not really do well. MA results. Okay, so MA results are how big? Lightning fast LSP server. Look, I have a stopwatch. And it just plain didn't find it. Okay. All the documentation for Miniaudio is in a comment, and Miniaudio is entirely resides entirely in one header file. So I'm pretty confident that I can find, oops. Okay, okay, so that's an MA result. It's an enum, and MacLeod is choking. Negative numbers. Does it give me any indication how big these things should be? Well, they're all negative except 0. We could say they're ints, but MA result, I'm going to guess size of MA result is 2. But who knows what the compiler might do. So let's just make it 64 bits for whatever, just because. So not uint, int 664. Why don't we just do this? G, there. Okay, I'm going to have to restart Emacs because once I load that header file, which is about 90,000 lines, Egglot just, I don't know if it's Emacs or if it's Egglot. Egglot's the LSP server that I'm working with, using. One of those two doesn't work so well. Where was I? I have lost my train of thought. How many people do I have in viewer land? Okay, so I don't have any irrelevant questions in chat. That's good. This is not intended to be an educational stream. And you find better educational streams elsewhere. We have one watching. Okay. Probably just me. Okay. All right, let's get back to work. Okay, so that's GMA error code, actual call value. Actual, well, that should be actual. You can tell I haven't compiled this because actual call value should be actual, we'll call it actual return code, but that's not true. What we're really going to call it is actual Miniaudio return code. Okay. Okay, not directly related to our error, our playback IDs, but we did tighten a couple things up. Okay, this has got to be, yes, this is probably, yeah. Okay, so find available slot. What on earth? My Emacs is sluggish. I'm going to stop it. And I'm going to restart. Yes, it's slow on the start. Okay. Okay, sound available slot. That is called by the playback functions, and what it does, as described in the comment above it, look for an available slot in gsound list and mark it as unavailable. Return slot index found or -1. So should I think I think we should return a playback identifier instead of an index. That's what we've been talking about. And return new playback ID with index with and we're definitely or error code. Contain, and I want to say containing containing index. Okay. Okay. So this ain't an int anymore. It's going to be a uint. Should I type def these uint 32Ts to, you know, S to playback ID? No. It serves no purpose. Unless I go to 64 bits. Or lower than 32. For whatever reason. So maybe we should type def this. So we're under the hood they're uint 32s, but other than that, they're going to be playback ID T's. Okay. And we'll just type def these up here. We'll type def up here. We'll type def where? We'll type def it right here. One thing we're going to have to do is organize all these global variables and such. So right now they're semi at the top, but they're kind of strung around. So we call that playback. Oh. This struct is getting kind of messy too. Okay, so all right. So now result equals no free slots. Is that an actual value? Yes. Okay, that's correct. I'm not okay. And then previous. So if something failed before, have I defined that? Yes. Okay. And then we lock the mutex. I'm not checking. Checking to make sure that we're free of race conditions or anything here. Well, that's probably the next stream because we're more than halfway through. And how long have I been going? $56 minutes. I'm going to stop soon, even though my my hourglass is not going a full hour. I sort of started it. Okay, lock the mutex. This can be. We go through each slot. We look for an available slot. If we find one. we say it's no longer available. The result, now here's where we have to, we have a function. And I forgot what I called it. Make playback ID, and it takes an index. And the index will be I. Go to exit. Why did I use a go to here? Because I didn't want a bunch of unlocks. I wanted one mutex unlock in the case where we have an error or the case we have success. Result is a playback ID and we're okay. Okay, I'm going to, this is cancel thread. I think we're going to stop here. We are 40% of the way through the file. It's the evening, it's 8:30, and I think the next stream will continue with item number 1. The code, just basically start using these playback IDs. Okay, that's all. I'm going to look at my clickbait. Where is my clickbait? I only answer questions related to the stream.